Use a graph and/or level curves to estimate the local maximum and minimum values and saddle points of the function. Then use calculus to find these values precisely. f of xy is equal to the sine of x plus the sine of y plus the sine of x plus y. For 0 is less than or equal to x is less than or equal to 2 pi, and 0 is less than or equal to y is less than or equal to 2 pi. The three graphs shown show different viewpoints of our function. From this graph, it appears at f of 1, 1, which is approximately equal to 2.6, there is a local maximum. At f at approximately 5, 5, the value is approximately negative 2.6, and this would be a local minimum. And at approximately the point 33, we see a saddle point. So now we want to find these points using calculus. So taking the partial derivative of the function f with respect to x, we get this is equal to the cosine of x plus the cosine of x plus y. And the partial derivative of f with respect to y is equal to the cosine of y plus the cosine of x plus y. Now we want to find the double partial derivatives. So the double partial derivative of f with respect to x twice is equal to the negative sine of x minus the sine of x plus y. The double partial derivative of f with respect to y twice is equal to the negative of the sine y minus the sine of x plus y. And the double partial derivative of f with respect to x and y is equal to the negative sine of x plus y. So now setting our partial derivative with respect to x of f equal to 0, and the partial derivative of f with respect to y equal to 0, and subtracting these two, we get the cosine of x minus the cosine of y is equal to 0, or the cosine of x is equal to the cosine of y, or x equals y, which can also be x equals 2 pi minus y. In the case where x is equal to y, and the partial derivative of f with respect to x equals 0, we get the cosine of x plus the cosine of 2x is equal to 0. And this can be written by 2 times the cosine squared of x plus the cosine of x minus 1 is equal to 0. And this is a quadratic in cosine x. Thus, we get cosine x is equal to -1, or 1/2. Which gives us x is equal to pi divided by 3, or 5 pi divided by 3. And this gives us the critical points pi, pi, pi over 3, and pi over 3, and 5 pi divided by 3, and 5 pi divided by 3. For the case where x is equal to 2 pi minus y, and the partial derivative of f with respect to x is equal to 0, we get the cosine of x plus 1 is equal to 0. And this gives us the critical point of pi, pi. Now we want to use the second derivatives test to test our critical points. So d of xy is equal to the sine of x times the sine of y plus the sine of x times the sine of x plus y plus the sine of y times the sine of x plus y. So the test on the point pi, pi is equal to 0, so the second derivatives test does not apply. However, our function of x(x), where y is equal to x, is equal to two times the sine of x plus the sine of 2x, which is equal to two sine x plus 2 sine x times the cosine of x. Simplifying further, this is equal to two times the sine of x times 1 plus the cosine of x So our function f of x(x) is greater than 0 for 0 is less than x is less than pi, and the function of x(x) is less than 0 for pi is less than x is less than 2 pi. Thus, every disk with center pi pi contains points where f is positive as well as points where f is negative. So the graph crosses its tangent plane, z equals 0, there, and pi pi is a saddle point. Now to test the final 2 points, the test on the point pi divided by 3, pi divided by 3, is equal to 9/4, which is greater than 0, and the double integral of f with respect to x twice of the point pi divided by 3, pi divided by 3 is less than 0, so our point f of pi divided by 3, pi divided by 3, which is equal to 3 times the square root of 3 divided by 2, is a local maximum. And now the test on the point 5 pi divided by 3, 5 pi divided by 3, is also equal to 9/4, which is greater than 0, and the double partial derivative of the function f with respect to x twice at the point 5 pi divided by 3, 5 pi divided by 3, is greater than 0. So our function f, evaluated at 5 pi divided by 3, and 5 pi divided by 3, which is equal to negative 3 times the square root of 3, all divided by 2, is a local minimum.